So I want you to take a second and just try to visualize a massive global corporation. Like, picture the gleaming headquarters building.
Yeah, the classic glass skyscraper.
Exactly. And inside, you have a CEO locked in a boardroom making these, high-level strategic decisions. You have quantitative analysts on the trading floor who are just crunching market data in real time.
Right, and probably some engineers deploying complex code updates.
Yeah, engineers, a marketing team running aggressive, highly responsive social media campaigns around the clock. Now, I want you to take that entire mental image and remove every single human being from the building.
Wow, just empty chairs.
Literally empty. I mean, the lights are on, the trades are executing, the revenue is flowing, but absolutely none of those roles are filled by biology. Not a single one.
It genuinely sounds like the setup for some kind of dystopian sci-fi movie, a completely zero human company. But the data we're looking at today proves it's really not fiction anymore.
Not even close to fiction. So welcome to this deep dive into the machine economy. We've been handed this towering stack of, well, technical blueprints, system architectures, user interface designs, and white papers, all originating from the Denarii DFi Orchestrator.
It's a massive amount of documentation.
It really is. And our mission today is to understand this monumental shift. We are moving away from the highly speculative early days of the internet, that Web3 era where you were basically just buying tokens and praying the line went up.
Right, the HODL era.
Yeah. We are transitioning from that into a self-operating execution layer where artificial intelligence actually runs autonomous real-world businesses.
And that transition is everything. Because if you look at the overarching philosophy across all these architectural sources, the core mantra is that execution beats narrative.
Execution beats narrative. I like that.
Yeah, historically, the internet has been this communication layer. We use it to read things, share things, talk to each other. But now it's becoming an execution layer where capital, logic, and decisions move at the speed of an API call. When a corporate system no longer has to wait for a human to wake up, drink their coffee and click approve, the fundamental physics of the economy changed entirely.
Okay, let's unpack this, because the sheer scale of the documents we're dealing with is honestly staggering. We are not talking about some hypothetical prototype sitting in a university lab that, might launch in a decade.
No, this is live right now.
Exactly. Denari's live system status dashboard shows 128,742 active autonomous agents deployed right now.
That's a staggering workforce.
And they have autonomously processed over $2.47 billion in real-world value. And they've maintained a 100% uptime while doing it.
See, that 100% uptime is the metric that should make every traditional executive sweat. Human beings have biological limitations.
Sure.
We sleep, we take weekends off, we get distracted.
We get sick.
Exactly. Machines simply do not. But to understand how a fully realized machine economy functions, we first have to understand how an AI workforce is actually managed. Because, you don't just boot up 100,000 language models, hand them a Tink account, and hope for the best.
Right. I imagine that would result in a company speedrunning its way to bankruptcy in about 4 seconds.
Unquestionably. So the Denarii system utilizes a platform called the Paperclip AI Orchestrator. Instead of a human interacting with a single chatbot window, Paperclip takes multiple autonomous agents and structures them into a rigid corporate hierarchy.
So it's literally an org chart for bots.
Exactly. You spin up a CEO agent whose sole job is global system alignment and resource allocation. Sitting beneath that, you have a quant agent that purely monitors liquidity pools to trigger instant arbitrage.
Wow.
You have an engineer agent that automatically audits external smart contracts for vulnerabilities before interacting with them, and a social agent that gauges market sentiment 24/7 to adjust the overall risk profile.
Okay, wait. I have to jump in here with a massive logical flaw in this whole blueprint, because we all know the baseline mechanics of how large language models work. They are stateless.
Right.
They essentially have amnesia. Every time a new session starts or a new API call is made, the context window just wipes clean. It has its baseline training, sure, but it has zero working memory of what it was doing 5 minutes ago. So how can an amnesiac run a coherent, quarter-long corporate strategy?
What's fascinating here is how the architectural blueprints solve exactly that. They actually call it the memento man problem in the documentation.
Like the movie.
Yeah, exactly. If a highly capable CEO agent wakes up with brilliant reasoning skills, but absolutely no memory of the company's current treasury status or strategic goals, it's entirely useless. So the paperclip orchestrator implements two mechanisms. The first is the heartbeat check-in system.
Like an automated pulse.
Essentially, yes. It operates on a recurring, rigid loop. Before any agent is allowed to execute a real-world action, the orchestrator forces it to digest a mandatory structured brief. Every single time that model wakes up, it is fed its designated persona, the overarching organizational goals, its active assignments, and a strict definition of what success looks like for that specific cycle.
So it's like handing a genius amnesiac a highly specific dossier the millisecond they open their eyes, saying, you are the CFO, here is the exact budget, here is what you need to achieve in the next 10 seconds.
Precisely that. But the dossier alone isn't enough to manage long-term projects, which brings us to the second, and honestly more critical mechanism,
Yeah.
the PRA memory system.
PRA.
Yeah. It stands for Projects, Areas, Resources, and Archives. It functions as an organized external filing cabinet for the AI.
But how does that not just overwhelm the AI? Like if you feed an AI its entire corporate history every single time, the token window will bloat, the model gets confused, and it inevitably crashes, right?
Right, but it avoids the bloat through vector databases and retrieval augmented generation. Instead of reading the entire history of the company every single time, the agent is trained to query only what it needs.
Oh, I see.
It learns to read from and write to specific folders in the PRA system. If it's working on a specific arbitrage trade, it only pulls the project file for that trade. It maintains a strategic through line across millions of reboots without ever overwhelming its context window.
Think about that just in the context of your own daily routine. Think about how much of your day is completely lost to context switching. You jump from a financial spreadsheet to an email thread, then jump onto a Zoom call, and it takes you, 15 minutes just to orient yourself and remember where you left off?
Oh, at least?
Yeah, so this PRA framework solves that exact biological inefficiency. It allows machines to instantly load complex, relevant context and pick up tasks without skipping a single beat.
It creates a perfectly aligned, instantly oriented workforce. But as you know, perfect memory doesn't mean perfect reasoning.
Which brings us to the elephant in the room, right? Hallucinations. Even if an AI model has perfect access to its PRA files, it still hallucinates. It confidently invents things. So what happens when a quant agent confidently makes a catastrophic logical leap while controlling tens of millions of dollars?
The researchers address this with a terrifyingly simple mathematical model they call the measurability gap. This gap is the divergence between two fundamental economic curves.
Okay, lay it on me.
Curve A is the rapidly dropping cost of using AI to automate a task. Let's call that C sub A. Curve B is the biological bottleneck of human verification. That's the cost of a human actually double-checking the AI's work.
Because eventually, checking the math on a complex trade takes a human just as much time as doing the trade themselves.
Exactly the problem. As the cost of automation approaches zero, humans face this overwhelming economic temptation to just let the machines run completely unverified.
Which sounds incredibly dangerous.
It is. The blueprints warn that left unchecked, this dynamic creates a hollow economy. It's a fragile house of cards system built entirely on unverified high-risk machine outputs that could cascade into a collapse at any moment.
The math in the source material paints a very stark picture of this. Let me bring this to life because it's wild when you break down the numbers. Let's say you have an incredibly advanced AI agent operating at a 95% accuracy rate per reasoning step.
Which is great.
Yeah, in human terms, a 95% accurate employee is a superstar. But if that AI agent is executing a 10-step autonomous financial task, that 95% doesn't just average out, it compounds.
Right, the errors multiply.
Exactly. You multiply 0.95 to the 10th power, and by step 10, the system has degraded to a 59.8% success rate.
The probability of failure grows exponentially with every subsequent action.
It's the worst possible game of telephone. You start with a pristine instruction, but if the AI makes one tiny 5% misinterpretation at step 2, it builds its next 8 steps on a totally flawed premise. By the end of the execution chain, the final trade is complete garbage. A zero-human company failing 40% of the time is a disaster.
It's completely unacceptable for an enterprise system. So Denarii couldn't rely on humans to close the measurability gap because that just introduces human latency back into the system. Instead, they introduce a native failsafe, the independent quality assurance agent.
Wait, so an AI auditing another AI?
Yes, but this isn't just asking the same model to double-check its work. That doesn't work. The QA agent is an entirely separate model operating under an isolated mandate and a much lower temperature setting.
Meaning it's less creative.
Right, meaning its outputs are highly deterministic and strictly constrained. It is explicitly prompted only to verify logical constraints, not to generate ideas. By forcing this dedicated QA agent to audit the worker agent at intermediate checkpoints, the compounding error chain is broken.
Okay, so the math changes.
Dramatically. If the worker agent is 95% accurate and the QA agent auditing it is also 95% accurate, the probability of an error slipping through both layers drops the end-to-end failure rate to 0.25%.
Wow. So the system mathematically resets the probability of disaster before the next step can even happen. That's brilliant. Okay, so we've established that we have these highly organized, context-aware, self-auditing AI agents that are highly reliable. But let's look at the physical reality of doing business.
Okay.
An AI agent can't exactly walk into a local Chase Bank branch downtown, show a driver's license, and open a corporate checking account. So where do these machines actually execute these trades?
Well, they require financial rails that don't recognize business hours, national borders, or human identity documents. They run entirely on decentralized ledgers. Specifically, the Denarii architecture operates on what they call the Trinity of DLT, distributed ledger technology.
Let's break down how this multi-chain setup actually works under the hood, because it's not just slapping 3 random blockchains together for the fun of it. Each network serves a very specific mechanical purpose for the AI.
They do.
First, they use the XRP Ledger, or XRPL. This acts as the speed and the muscle, the liquidity routing engine. It gives the AI agents sub-5-second settlement times. And when your AI is trying to execute arbitrage across global markets, I mean, milliseconds matter.
That speed is paramount, because if a trade takes 10 minutes to settle, the arbitrage window has already closed.
Right. Then, for the core logic execution, they use Algorand. The blueprints specifically highlight Algorand's pure mathematical finality, which is crucial because it means there is zero fork risk.
And we should clarify why an AI model cares so much about fork risk. If a blockchain forks, meaning it temporarily splits into 2 competing versions of the truth, human traders just wait it out. They get a coffee and see which chain wins.
But an AI doesn't drink coffee.
Exactly. An AI agent operates instantly. If it executes a complex multi-leg strategy and the blockchain reorganizes underneath it, the AI's internal PRA memory becomes totally desynchronized from the actual state of the chain. Algorand prevents that state desync from ever happening.
Gives the AI a solid floor to stand on. Finally, you have Hedera HBAR. Hedera utilizes a gossip protocol for high-throughput consensus logging. It acts as the meticulous accountant, basically an immutable, chronologically perfect tape drive. Every single decision, audit, and action the AI swarm takes is permanently ordered and logged there.
It's also crucial to point out the economic necessity of this specific multi-chain posture. If we look back at early Web3 experiments with automation, they completely stalled out due to gas fees.
Right, the network fees were outrageous.
If it costs $20 in network fees to execute a simple smart contract on a congested network, an AI agent cannot profitably run a high-frequency microtransaction strategy. By routing through this specific trinity of DLT, the system strips out the cost barriers. It allows the workforce to execute thousands of cross-chain actions with near zero friction.
Okay, so the technical execution is flawless. The agents are trading across fast blockchains. They're making mathematically sound decisions and avoiding token bloat. But this hits a massive real-world wall. Let's say I'm the CFO of a traditional enterprise, or worse, I'm an auditor for the IRS.
Good luck.
Yeah. How on earth do I make sense of a random string of cryptographic numbers generated by a machine swarm on a decentralized ledger?
You've just hit on what the sources identify as the opaque ledger problem. A blockchain transaction hash is a mathematically perfect proof that a specific amount of digital value moved from wallet A to wallet B, but it is entirely devoid of semantic context.
Right, the hash doesn't tell the IRS what the AI bought, who the vendor was, or why the CEO agent even authorized the spend. It's just cryptographic alphabet soup.
If we connect this to the bigger picture, a machine economy cannot scale if it operates in a shadow ecosystem. It must interface seamlessly with the traditional human-run fiat economy. To solve the opaque ledger problem, the orchestrator introduces a framework known as Auditable Machine Commerce, or AMC, which runs on an HTTP native payment protocol called DP402.
Here's where it gets really interesting. Because a new protocol is needed, but the blueprints detail a specific piece of middleware called the Factum engine. Think of the Factum engine as a universal translator between the blockchain and the corporate accounting department. It works by forcing the AI agent to attach standardized metadata payloads, basically digital receipts off-chain, which are cryptographically linked to the on-chain transaction hash.
So the semantic context is tied directly to the mathematical proof of the money moving.
Exactly. The Factum engine pulls both the on-chain hash and the off-chain metadata, verifies the link, and then compiles it directly into standard ISO 20022 XML formats, specifically formats like the CAMPIT.054 cache management statements.
Right.
And I know XML formats sound unbelievably dry, but the implications are staggering here. This engine literally translates robot money into traditional compliance documents that legacy enterprise ERP software, the exact same software running at Fortune 500 companies right now, can instantly ingest and understand as a standard bank statement.
It completely bridges the gap. It maps the AI's identity, the specific digital asset purchased, and the strategic authorization code directly into the standardized XML tags required by global banking networks.
I want you to think about what this means for the modern business. This tech bridges the hyperspeed sci-fi reality of autonomous ledger trading with the incredibly boring, rigid accounting software sitting on your work computer today. The documentation estimates that by replacing human administrative friction with this automated straight-through processing system, businesses can save up to $100,000 a year in manual reconciliation overhead alone.
It pulls the decentralized web out of the speculative shadows and turns it into a fully compliant, enterprise-grade processing engine.
But, integrating into enterprise ERPs means we are handing autonomous software the keys to the corporate treasury. With these systems holding that much financial power, how is it secured? And who is actually allowed to turn the machine on in the first place?
Well, security is the foundational layer here. The blueprints outline a highly restricted core known as the vault. This relies on intense hardware-level protections. We're looking at quantum security shields and secure T enclaves.
T meaning trusted execution environments.
Correct. They are essentially isolated, hardware-encrypted black boxes within the processors. Even the host operating system cannot read the data while the AI agents are processing sensitive private keys inside the TE.
That's intense.
Add to that decentralized biometric scanners that require multiple physical human verifications for major state changes, and the vault is incredibly hardened. But the network access gate itself is the most fascinating security parameter. You don't just pay a monthly SaaS subscription to access the paperclip orchestrator. No, operators must cryptographically prove they hold 2% of the total DFI token supply just to access the root tier controls.
2% of the entire global supply. That is a massive, multi-million-dollar barrier to entry.
It's designed to enforce absolute economic alignment. It transitions the DFI token from a speculative asset that people day trade on exchanges into a literal high-stakes utility key. You must have massive skin in the game to command this AI workforce.
Which makes sense. But it also creates a huge learning curve.
Yeah.
You can't just hand a human operator the controls to a multi-million-dollar autonomous financial swarm and say, good luck, try not to crash the global treasury.
This raises an important question. If the keys are this guarded and the system is this complex, how does anyone actually learn to pilot it without risking systemic ruin?
Well, they built an incredibly detailed training ground. The documents dedicate a whole section to the agent sim game. It is a gamified, highly interactive sandbox embedded securely within the orchestrator. Before you ever touch the live mainnet, you're placed in this visualization where you can physically see holographic capital streams flowing between the different AI agents.
It allows the operator to intuitively grasp the economic physics of the system.
But it gets better. They built an AI Dungeon Master mode. This uses a live adversarial language model designed to actively attack your simulation.
Oh.
Yeah, you'll be running a simulated quarter, and suddenly your dashboard flashes red. The Dungeon Master injects a synthetic crisis, say a flash loan liquidity drain, or a simulated Oracle manipulation event. It instantly crashes your simulated treasury, and you, the human operator, have to use the AI tools to diagnose the threat, isolate the compromised worker agents, and deploy a self-healing patch to save the company.
It's an aggressive incident response simulator. By the time an operator actually passes the 2% token gate and deploys real capital, they have already survived dozens of catastrophic simulated black swan events.
It is quite literally flight school for the machine economy. So let's pull all of this together. We have traversed a massive architectural shift today. We've seen the transition from speculative Web3 hype into a self-operating execution web.
Right.
We've explored AI agents that are managed like strict corporate hierarchies, utilizing parity memory to maintain context, and independent QA agents to break the compounding mass of hallucinations. We've seen the DLT Trinity providing the lightning-fast rails, Factom engine flawlessly translating cryptographic hashes for legacy IRS compliance, and military-grade vaults securing the perimeter.
It is a fundamental rewiring of digital commerce. It removes biological latency, human weighting from the center of economic value creation.
So what does this all mean for you? As you log into your computer tomorrow morning, I want you to take a hard look at your actual daily workflows. Are you doing essential, creative, deeply cognitive work? Or are you just acting as a biological router? Are you simply moving an email attachment to a spreadsheet, formatting it, and passing it to an approval system? Because those structured inefficiencies are exactly what the Denarii Orchestrator is built to execute in milliseconds.
It's a sobering reflection on the future of work. And I want to leave you with a final thought to ponder. Something buried deep in the appendices of these blueprints that we haven't touched on yet. The architecture contains schemas for what they call autonomous identity profiles.
Wait, identity profiles for the machines?
Yes. In this mature system, the AI agents don't just execute tasks. They build their own portable, on-chain trust scores based on their historical success rates. They generate smart contract mandates, negotiate terms, and objectively grade the performance of other entities on the network.
That's wild.
The provocative question here is this. In a future where software autonomously buys, sells, negotiates, and maintains a perfectly verified reputation, how long until human employees find themselves logging into an interface, submitting their resumes, and interviewing for jobs managed entirely by an algorithm?
That brings us right back to our very first image, doesn't it? The corporate boardroom with no humans in it. Only now you might be the one standing in the hallway waiting for the machines to decide if you get the job. Incredible stuff. Until next time, keep diving deep.